In this example, we're going to use calculus to develop a formula from geometry. The volume of a cone is 1/3 the area of the base times the height, or 1/3 pi r squared h. Remember how this works. A cone, has sort of this shape. The height of the cone is there, and the radius, is across the bottom of the cone like that. What we could do to look at this, we'll imagine taking just a line. We want the bottom here to be r and that h, so that this coordinate would be r comma 0, and this coordinate up here would be 0 comma h. And we want to find that line. The slope of this line is just change in y over change in x. That's just going to be negative h over r. And the y-intercept is just h. So this line, mx plus b, is going to be negative h over rx plus h. Right? That's the equation of that line. And now I'm going to want to rotate that around the y-axis. So I'm going to want my rectangles to look like this. But that means now my radius has to be in x, so I need to solve this equation for x. So I'm going to multiply by r times y equals negative hx plus hr. So hx equals hr minus ry. So x equals hr minus ry over h, or that would just be r minus ry over h. So if I just look at a disk, that's going to be pi r squared times delta y. R is just this length of the rectangle. That's just that r coordinate there. So that's going to be r minus ry over h squared. So r times r is going to be r squared. We're going to get r squared y over h twice. And then we're going to get r squared y squared over h squared delta y. So that my overall volume is going to be the integral then for y coordinates. Now, what are my y coordinates going between? Here at the bottom, my y coordinate is 0. At the top, my y coordinate is h. So y is going from 0 to h. Pi, we get this r squared minus 2r squared y over h plus r squared y squared over h squared dy. We can pull the pi out. Now, when I take the antiderivative here, remember y dy, that's my variable. The r and the h are constants. So when I take the antiderivative, I don't do anything with the r's or the h's. So the antiderivative of r squared is a constant. The antiderivative of a constant is just the constant times y. This next one, I'm going to increase the exponent on y by 1 and then divide by that new exponent. Same thing here. I increase the exponent on y by 1 and then divide by that new exponent. So let's see here. These 2's cancel out. So I get pi. So I plug h in for y. R squared times h minus r squared times h squared over h plus r squared times h cubed over 3h squared. And then when I plug in 0 for y, r squared times 0 is 0. R squared times 0 squared, that's 0 over h. R squared times 0, that's all just 0. So we get r squared h minus r squared h plus 1/3 r squared h. Well, these cancel, so I'm left with 1/3 pi r squared h, which is exactly the formula we were supposed to have. So sort of cool that we could actually verify these formulas from geometry that we've known for a long time. Calculus can help us come up with some of those and verify that they're actually correct.